All right, so should we just go through them all? Just because we can? Okay, so number one, what? You're starting with matrix A. And matrix B. And we want to find some things. So A minus B, you just subtract the corresponding thingies, right?
Yeah.
So 4 minus negative 3 is 7. 6 minus 5 is 1. 1 minus 2 is negative 1. And negative 7 minus 6 is negative 13. Everybody get that?
Got it.
Got it? Okay, B, you add them together instead. 4 and negative 3 is 1. 6 and 5 is 11. 2 and 1 is 3. Negative 7 and 6 is negative 1. And C, did you get that wrong? Oh, okay. C, 2 times A just means double all the numbers in A. So 4 becomes 8, 6 becomes 12, 1 becomes 2, and negative 7 becomes negative 14. And then D is a little bit tricky. I'm going to do 3B first. So, I should write out the problem. 3B minus 2AB. So I'm going to figure out what 3B is first. So that's going to be negative 9, 6, 15, 18. And then I have to figure out what A times B is before I double it. Okay? So to do A times B, I have to go across times down. So that is negative 12 times 12, and then add them together, which is 0. I go this row by that column. So 4 times negative 3 plus 6 times 2. And then I go this row times this column. So 4 times 5 is 20. 6 times 6 is 36. Add those together and get 56. Then jump down here to this row times this column. So 1 times negative 3 is negative 3. Negative 7 times 2 is negative 14. So that is negative 17. And then if I go this row times this column, I get 1 times 5 is 5. And negative 7 times 6 is negative 42. So that gives me negative 37. Okay, now I need to double all of those. And I want to make this plus. I like adding better than subtracting. So I want to multiply all of them by negative 2. You could multiply by 2 and then subtract. So I'm going to multiply by negative 2 and then add, okay? So that's 0, negative 112, 34, and 74. So now if I add those together, my final answer is negative 9, 40. What is, I'll do the easy one first. E, that's 92. Negative 97. Negative 97. Okay?
Over there.
Okay. On.
All right, so number 2, you're given matrices again, and these are 3 by 3, and so you could multiply them, I'm sure, by hand, right? But
I could, but
it's probably easier to do it on the calculator, so let's do that. So A is a 3 by 3, and I have 4, 2, 1, as the first row, negative 2, 4, 3, as the second row.
I'm looking at 1D. I'm trying to figure out where you
Freaking out. What is it doing?
3 by 3.
Okay, so there's my matrix A. Then to get matrix B, same thing. This is a 3 by 3 also. And the first row is negative 6, 3, 7, and then 3, 2, 0, and negative 2, 1, 6. Okay? Right? So you just enter it in, go back to your home screen, and then go A, B, whoops.
Okay.
Yeah.
Need B.
Okay. And so you get that for A times B. Is that what you got?
Yep, that's exactly what we want.
Sweet deal. And then for the next part, you do the same thing but backwards. So we want B times A, and notice that that does not come out to be the same.
Check.
In other words, matrix multiplication is not commutative.
Never said that.
You said that like yesterday.
Yeah, we were hanging out yesterday talking.
I was busy.
Oh yeah, you're real busy.
All right, 3. We're going to go A times B first. And what do you notice?
We need to think about B. We can't.
We can't. Because if I try and go this row across times this column down, since this has 2 entries and this only has 1,
Not
can't
possible.
do it.
Put
So
mismatch.
dim mismatch, dimension mismatch, yes.
It was second one, right?
Okay, second one. Now we're going to go backwards.
JK.
So we're going to go this row across times this column down, and you can do it. So 4 times negative 6 is negative 24. Negative 1 times negative 2 is 2. And so if you add those together, that gives me negative 22.
Yeah.
Okay? And then that's it for that one. And then I have to skip over to this column. So if I go across and then down, that gives me 4 times 3 is 12. Negative 1 times 7 is negative 7. Add those together and get 5. So that one you can
Yep.
actually do.
Complicated.
Hi, looks like Amy.
Okay, number 4. Find the inverse of 5, 4, 3, 2.
There's no,
No, because I couldn't figure out how to do that on the computer. There's no brackets on it. But there should be. There's an
I don't
answer.
even
Yeah.
realize
What's the inverse of this matrix?
negative 1. I mean, no, I
I
don't
don't
know.
know. What do you get?
Negative 1, 2,
Negative 1, 2.
1.5, and negative 2.5.
And did you just do that with the calculator?
Yeah.
Okay. And then what that means, since they're inverses, is if I multiply this by this, what am I going to get?
So then you just do like,
So 5 times negative 1 is negative 5. 4 times 1.5 is 6. So that adds up to be 1. Right? If I go this way times that way, I get 10 plus negative 10 is 0. If I go this times this, I get negative 3 plus 3, which is also 0. If I go this times this, I get 6 minus 5, which is 1. So that's what it means for them to be inverses, right? When you multiply them together, you get,
How do you do inverse of that? You're talking about it again.
on the calculator,
okay,
you
so
just...
no matter what, do we have to do that second part?
Nope, I'm just being a teacher. You just type in the matrix.
Okay, I got it.
We already know that.
So
Sorry.
after you do that, then we're done right there.
You don't need to graph.
Yeah,
Do you have to do the 1 0s?
I just asked.
Okay, that's just.
that's just me being dumb.
I was trying to help Ryan.
Well, she can listen too.
No, she was helping me. Yeah.
Thanks, ask that.
You shut.
Please come back, Chad.
Yeah.
Sure you know what to say.
Fantastic.
Okay, 5A. How do you want to solve this one?
Such weird.
No.
Elimination.
No.
Elimination. Multiply the top one by
Yeah, I couldn't think of what it was called.
Multiply the top one by what?
negative 4.
Negative 4. So that's going to give me negative 8x plus 20y equals negative 40. Okay? Add those together, so I'm done with this now. Add those together, the x's cancel. 2y and 20y is 22y. Negative 4 and negative 40 is negative 44. So y equals negative 2. Which equation do you want to plug that into to figure out what x is?
Bottom one.
The bottom one? Are you for reals right now?
Yeah.
Okay, so negative 8x, if I plug negative 2 in
Negative
there for
8x.
y,
It is negative 2.
What are you talking about?
Oh, no, that
Oh, you mean plug in the bottom one of the original ones, like that one? Okay. So 8x plus 2y, what's 2 times negative 2? 4. Negative 4 equals negative 4. So x equals 0, because the negatives 4's cancel. 8x equals 0, x must equal z.
Let's do matrices.
Huh?
Let's do matrices.
Could have gone matrices on that one, yeah.
Let's do it.
I don't know, that might have taken more time though. For B though, since we have 3 variables and 3 equations, matrices is probably your easiest way to go. Do you want it for funnies, do it another way? No? No. Okay. So I have to be careful with my matrix in this one. These are all my x's, so for the first one it's going to be 2, negative 1, and then 0, because there's no z. For the second equation it's 1, 0, and negative 1, because there's no y. And for the last one it's 0, 1, and 1, because there is no x.
Does it mean anything if the zeros are in a diagonal?
Nope, doesn't mean anything fun. So now I'm going to take the inverse of that times 10, negative 1.
Why change the inverse?
Because my original equation is this. What do you want to call this original matrix? A. Okay, so if I rewrite this as in the original equation form, it's A times X equals B. And I'm going to try and solve that for X. So I'm going to multiply both sides by the inverse matrix. So the A's cancel, and X, which is really X, Y, and Z, equals A inverse times B. Okay?
You said the same thing for six,
Yep. So what did you guys get for 5P?
0, negative 10, 1. Yeah.
0, negative 10, 1. And if you want to, you can check that. If I plug in 0 for X and negative 10 for Y, then I get 10, so that works. If I plug in 0 for X and 1 for Z, negative 1 equals negative 1, so that works. And if I plug in negative 10 for Y and 1 for Z, negative 10 plus 1 is negative 9, so that works also.
Wait, so if you use the calculator, you're going to do the A, and then the negative first, and then you multiply it by?
B. By B. And that will equal your answer.
Can we skip the last?
No. Is there any reason for us to do number 6?
No.
6 is the same as the one we just did, right? This time we're going to have a 4x4 though, but no big deal. All right, number 7. All right, these are fun ones. Let's go fancy graph. Okay, so I guess this one A, you're just asked to graph them. So I'm not going to necessarily just stick with the first quadrant. What can you tell me about the graph of negative 2x plus y is less than or equal to 3?
Solve it for y.
That's a negative 3.
Negative 2x plus y is less than or equal to negative 3. So you took and solved this for y. So you added 2x to both sides, you get y is less than or equal to 2x minus 3. So what do you say, Bobby? Okay, crosses the y-axis at negative 3. Up 2 over 1. Up 2 over 1. Up 2 over 1. So there's that one, right? Is that supposed to be dotted or solid?
Solid.
Solid. Okay, then the next one is 2x plus 3y is less than or equal to 6. So you solved that for y also? Okay. So this is 2 steps to solve for y, right? It is subtract 2x first. So 3y is less than or equal to negative 2x plus 6. And then you divide by 3. Y is less than or equal to negative 2/3 x plus 2. So it starts at what?
Good.
2. And then from there I go
Down
down 2 over 3. And down 2 over 3. And this is going to be solid or dotted? All it is. Okay, and then I need to do some shading, right? So it's less than this one right here. And it's also less than this one right here. And so my solution area is where those two shading things overlap, right? What's that area there? I just want to be fancy. That's how I am. Okay, so B is the same one, but now we've got some gross numbers, right? But the good news is it says x is greater than or equal to 0 and y is greater than or equal to 0, so we only have to mess with the first quadrant. If x plus y is less than or equal to 20, where is that going to cross the x and the y axis? At 20 and 20. How about 200x plus 50y is less than or equal to 2,200? Where will that cross?
11 and 44.
11 and 44. Which one is the 44? The x and the y. Okay. So the y values need to go all the way to.
Y is to go to X is to go to 20.
X only has to go to 20. Okay, so we're good. All right, so first one, x plus y is less than or equal to 20. Crosses here at 20. Crosses here at 20. Okay. Then it says 200x plus 50y is less than or equal to 2,200. So that crosses the x-axis at what? 11. And the y-axis at what? 44 even? So that's that line. And then we also have the x-axis and the y-axis. So, are we less than on both of these? Yep. So our region is this. Good cool, huh?
What does it mean to label all the x and y intercepts?
Okay, so then they also want you to say this x or y intercept right here, where does it cross? 0, 20. This one is
We gotta do all of them?
0.44. This one is 11.0. This one is 20.0. And then this is a corner point right there. What's the coordinates of that point?
8, 12.
12. So that's what they mean by label all x and y intercepts. What did you say? That's your what?
My address?
8, 12. That's your address?
Half of the address.
Oh, half of your address. All right, and then the last one is the fun one, because you actually have to figure something out with it.
Okay, I got a question.
Okay.
For, like how we did the last one,
Mhm.
how we got 44, are we just dividing under by 2?
Yep. We went 2,200 divided by 50, and that's how we got 44. And 2,200 divided by 20, and that's how we got 11.
Okay.
Okay? So we could have done the same thing with 7A.
Why
Anytime.
did you do 2,200 divided by 20?
I'm at 200. Sorry.
I know we have.
But then you said 20.
I don't know what I'm talking about. Alright, so let's take a look at this one, and let's do the same thing. If 10x plus 20y is less than or equal to 140, it's going to cross the x at
14.
14, and then it's going to cross the y at what? 7. Alright, and then if you look at the next one, it says 6x plus 8y is less than or equal to 72, so that's going to cross the x at 12, and the y at 9. So that means I can use a nice big scale for this one. The x's only have to go up to 14. And the y's go to... Alright, so let's do some graphing. So 10x plus 20y, I need a dot at where and where?
14, 7.
14 on the x, 7 on the y. 6x plus 8y, I need a dot at 12. Oh, I didn't make my line yet. That would have gotten more confusing. 12 on the x. I don't know. That line. And while we're here, let's make a little mark where they use x. And then we do the x and the y, right? And were these both less than?
Yeah.
Yep. So it's this region inside here. Okay. That's good stuff. Does it come up in a different color? Yeah. All right. So now we have to figure out the quarter points of this. They are 0, 7, 0, 0,
12, 0.
8, 3. Okay, so we have to take those and plug them into our cost function. And we want the minimum and the maximum. So obviously the minimum is going to be right here. The maximum will be, you think so? 64 plus 36 is 100. What is it here?
96.
Oh, close. Same here. 84. So there's the maximum. Okay? That's it.
How do you find that point, like, you know, the A3 one?
If you don't have this sweet graph like I do,
Can we just use your graph?
you take the two equations that were used to make that line, which in this case was 10x plus 20y is less than 140, and 6x plus 8y is less than or equal to 72, and you solve them. You've got 3 ways to do it. How do you want to solve it? You go matrices. So you could go 10, 26, 8 inverse times 140, 72. That's another way if you don't want to take all that. Yeah, it's not really set up very well for elimination, but you could do it that way and it would work out. Okay?
Are we turning these ones in?
Tomorrow, yeah.